Yasas Karisto Hume Proskelesate Na Miliso Maz Samira. Ta Linaika Mu Den Inai Toso Kala Opara Ta Miliso Anglica. So I know that I just totally butchered your language, and I do apologize. I did my best. And just in case I didn't say exactly what I think I said, good evening, and thank you so much for inviting me to share with you some of the modifications that you may consider making to HVAC systems in order to reduce some of the risk of transmitting infectious aerosols in the facilities that either you manage or your clients manage. Okay, so just a brief disclaimer here. You guys know ASHRAE, you know how it is. So this is a pandemic. Everything is constantly changing. It might be even changing right now, this very moment, every day. So while every effort has been made to make sure that, that this is current and please understand may be changing, like I said, this very moment. So this information represents general principles be used in conjunction with information specific to any building system be looking at. So just some learning objectives. Hope that you get out of this presentation an understanding of just the 4 basic HVAC related strategies to reduce indoor transmissions, and that you understand and be able to explain the impact of maintenance, filtration, cleaning, ventilation, and humidity on indoor air quality, as well as be able to assist your customers in developing risk mitigation plans. So most give a thought to how air gets in the buildings they occupy. They usually think it's just an extension of the outdoor air, but you both know that and specifically brought in from the outside is processed air. It's been cleaned, it's got to be cooled and heated, dehumidified, and humidified. And it gets moved around the building to the places where it's needed to do the work of maintaining acceptable indoor air quality. That is the air quality or that air with which there are no known contaminants at harmful levels, at concentrations, and with which about 80% or more of exposed are satisfied. But there are challenges to achieving and maintaining acceptable indoor air quality. So occupants may be wearing colognes or perfumes, they may be producing bioeffluents, they may have colds or viruses that they bring in with them. The buildings are full of furniture and carpet and drapes. These things we may be performing tasks like painting or welding, woodworking. Come inside, we have dirt on our shoes and we open doors and windows. This allows insects and all sorts of pollens and things to come in. In addition to all of the biggest challenge to acceptable indoor air quality right now is the SARS virus that causes COVID-19. And we know that when people cough, sneeze, or sing, or talk, or even breathe, they expel particulate matter. And if they're infected with COVID-19, particles expel. We know that because of their weight, some of the larger particles, the droplets, tend to fall out of the breathing zone within a relatively short person who expelled them. But they don't always land on the floor. Sometimes they land on a desk or a partition wall, a bookcase, a chair, some surface that somebody might touch and then inadvertently touch their face or their nose, their eyes, and infect themselves. And not all the expelled particles are the same size. Some are larger and some are smaller. The smaller ones don't have the weight to pull them down. So these can travel distances, potentially infecting people far outside of that original infected person. We also know that in environments where humidity, larger particles that may have had a considerable coating, if you will, of saliva on them, these can quickly desiccate and aerosolize. They concentrate any pathogenic materials that may have been present in them. becoming more effective, and they shrink in size so that now they can float in the air for extended periods of times, days, hours, weeks, increasing the likelihood or the potential that somebody is going to get infected. We also know that we can use our HVAC system to change the indoor environment and improve the odds in our favor. There are 4 basic strategies to using the HVAC system: maintenance, ventilation, filtration, humidity control. There are also some advanced strategies like adjusting airflow patterns to limit exposure to the today. Before you make any modifications to anything in the building, the first thing, make sure that we establish our facility management team. We want to understand that they are being asked to put together a pandemic response plan, and that it needs to be specific, achievable, and relevant to the building under consideration. And it needs to take into consideration the building's resources, or the building owner's resources in terms of time, people, and money. If there is one, the team will want to review the facility operating manual to understand how the facility is currently operating, to understand how things are currently done, and then together your plan of action to determine changes you're going to make to the operating procedures. You'll want to make sure that you document these things and then adequately communicate them to the entire facility team. Monitor and track the impact of your changes so that you can see if the things that you've put in place are helping, if they're doing what you wanted, any unintended consequences, and how all of this impacts your bottom line. You're also going to want to have a set time to revisit your changes and determine if it keeps them in place or if you can return to your previous protocols. And then you also want to be sure that to continue your regular building performance reviews. If you don't have this already, then you'll want to start that. The next thing that you're going to want to do is to, specifically if your building has been dormant, not all buildings have been unoccupied, building has been dormant, the next thing that you want to do is definitely address waterside concerns. You're going to want to do a thorough flush. Now, this presentation does not get into the details of that flush, but there are ASHRAE resources and resources that can assist you in that process. Needed. All right, so let's talk a little bit about system maintenance. Before you begin making changes to your existing equipment, you want to make sure everything is working properly. Those two. HVAC equipment is often it's in the basement, it's on the roof, and so it often gets forgotten until something's broken. But this is the equipment that is largely responsible for maintaining the indoor environment. And if you don't take care of it, it can't take care of you. Right? It's like a car. If you can buy an entry-level car, or you can buy the top-of-the-line car off the showroom floor. But if you don't change the oil, if you don't flush the radiators, if you don't rotate the tires and put gas in them, neither one of them is going to take you where you want to go, right? So if damp and if filters are installed backwards or not at all, if they're not changed frequently enough, if you've got torn bird screens, if your ductwork and diffusers and grills are all filthy, then there's no way that this equipment is going to be up to the challenge of providing acceptable indoor air quality, right? It's like putting a boxer in a ring, one hand tied behind his back. So you want to be sure to review your maintenance. And if you have any deferred maintenance, you want to make sure that you get that scheduled and get that work done. Usually when they're bad, the first budget that gets cut is maintenance. And when things are good, the last budget to be considered is maintenance. So very often we find our facilities with a lot of deferred maintenance that needs to be done. And so we want to make sure that we get that addressed We also want to make sure that as we're doing that, that we definitely check our actuators. We want to make sure that these things are properly calibrated. The last thing we want is to have a building automation that the outside air damper is at 100% when it's really only at 50. All right. Since we're dealing with a virus that could be captured by components in the HVAC system, actually there are some that is designed to capture them. Any staff whose job requires them to be in contact with potentially contaminated components, filters, coils, drain pans, etc. These folks should be wearing PPE. At the very least, they should be wearing gloves, and they should be wearing safety glasses and an N95 respirator, and they should be fit. I'm not sure, how things are going in Greece and in the U.S. A lot of times, folks just haven't had it fit tested by a doctor, by a physician. A lot of times when people think that of the term fit test, they think, oh, just does this thing fit my head? The other thing that we really have to think about is, are you fit to wear the respirator while doing your job? So we want to make sure our maintenance staff who are wearing these can do their jobs. They can go and they can change filters, they can climb those ladders and get to the roof, or they can get to the mechanical room. And they need to do while wearing that N95 or higher grade of respirator. And then of course they will follow all the recommendations. You want to make sure that you're looking at ASHRAE standard 180 as well as the standards for cleaning HVAC equipment and ductwork. Of course, if you have, if there are any protocols or requirements or orders in place in terms of how you handle the filters, then you want to make sure that you're also following those. Here in Michigan, we're just double bag filters, and then they're just disposing them as they normally would. But some folks are saying, no, we need to handle this a little differently, and make sure that you understand what the requirements of your municipality are as you're beginning to do that work. Then you want to do an air cycle. You welcome your occupants back to the building. If the building's been vacant, again, just like it's got that stale, stagnant water sitting in it, it's got stale air sitting in it, and you want to get that out of there. To do that, if possible, depending on the capabilities of the equipment, you'll want to operate the system with 100% out for long enough to get somewhere between 4 and 8 complete air changes. That means you've taken all the air out, not just, it's not an outside air change, air change. You want to get all of that out and bring in all new air at least 4 to 8 times. If you can't with the existing equipment, you open windows or doors or install temporary exhaust fans to help you accomplish that. After that, you want to operate 24 hours, and you want to monitor and trend all the building performance metrics. Is it able to maintain set point, for airflow? Is everything working like it's supposed to? Does anything need to be adjusted or repaired or replaced? You want to be able to answer these questions. And finally, you want to do a daily flush once the building is reoccupied, at least 2 hours after occupancy, or however long to achieve 3 air changes, to ensure that you've got good clean air, or that the air that may have been breathed in, right? It's been contaminated. People have coughed and talked and sneezed in that air. And you want to make sure that you exhaust all of that so that you have a station of clean, acceptable air to start off your next occupancy cycle. So let's talk a little bit about ventilation. So we need our ventilation of that old air that we've breathed and coughed in. And we do this through what we call ventilation because it reduces the concentration of contaminants in the space. Those contaminants concentrations are reduced. So is the probability that somebody else in the facility might get sick. might get infected. So this graph here is adapted from the Riley equation, and it's just showing you here that, and I'm not sure if you see my mouse or not, but I am using it, so hopefully you can. So here you've got your pollution concentration, and you've got 3 curves here for different source strengths. And you can see that when you get around when you air changes per hour, that you, for whatever pollutant source strength you happen to have started from, when you get to around 3 air changes per hour, it's reduced almost to its level point, right? It's not always going to get, it's never going to get to 100, but it can get pretty low. You can get it, you can be, down to 90% or 95%, 99%. So depending on the source strength. So there are a couple of ways to do that. First of all, you economize our system that's existing. You want to certainly maximize. If you need to possibly reset the economizer damper minimum position to bring in more outside air, you may consider doing that. If it's already sized for 100% outside air, then that's where you want to be operating, as long as you can still meet the load. If the system has, for example, an infill that's in good working condition and well maintained, then you want to continue using it. But if you know the ERV has not been well maintained, or if you're unsure about it, then you don't want, there could be a risk of cross-contamination, and you want to take a step back. You want to perform the appropriate maintenance, possibly retro commission or recommission that equipment before you. Bathroom exhaust is another opportunity. Often these are interconnected with occupancy sensors. Those can be temporarily decoupled and the fan 24/7. You want to be sure when you're doing this that that your floor traps are primed, so that you're not bringing sewer gases into the breathing. And you want to also make sure that you disable hand dryers because they can blow contaminants around and disrupt airflow patterns. You could also, again, just run the equipment longer, again, typically 2 hours before and after occupancy, or enough to get those 3 air changes. And oftentimes people ask, how much ventilation should I be trying to bring in? And there's not a hard and fast number, right? Every facility is different, and so the answer is really as much as your facility and budget will allow, right? So we have to bear in mind that this increased ventilation does not come without a price. When we bring in additional air, it has to be cleaned. It's got to be heated, cooled, humidified, or dehumidified, and then building. So that means that the HVAC equipment is going to be consuming more energy than it did previously. So to make sure that the equipment is going to have the necessary excess capacity to still meet the load under these new. And we need to also be prepared for those higher energy bills. If the building has done an energy upgrade, for example, a lighting upgrade, those are really popular in Michigan right now. We've got utility rebates for those. And so if you've done a lighting, that is a good thing, because that saved energy will give you a little bit of extra capacity for the energy, the additional energy that the increased ventilation system might use. In this particular graph here is showing just looking at a very simple system, 10,000 CFM. You can see here the criteria for the system. It's an 8-row coil, 44-degree chilled water temperature, return air temperature 76 dry bulb, 66 wet bulb, and leaving air temperature of 52, pretty almost saturated, right? And with increasing outdoor air percentages here, we can see that it just creeps up as we outside air, right? So we end up with twice the required chilled water flow rate, twice the required cooling, right? So it's very unlikely that this is going to be able to provide that. But you want to, when you're doing your assessment, you want to know how much can your system provide? What's the limit of the equipment that you've got? Some of the things to think about when you're looking at increasing your ventilation, you're definitely going to want to temporarily disable any demand control ventilation that you may have, or static pressure or temperature. These things modulate your outside air based on the number of people that are in your space, and you don't want to be doing that right now. You want to bring in the maximum amount of outside air for which the system was designed, regardless of how many people are actually in the space. And you may have to, excuse me, you may have to reset some of your set points for temperature and things like that to make sure that you can keep the space comfortable. It's going to be a balancing act, right? It's going to be an iterative kind of thing. And you also want to make sure that you are not using portable fans or ceiling fans, things of that nature. These can disrupt your airflow patterns, and you don't want that right now. If space heaters, we do that often here in Michigan because it gets cold. So if people have space heaters, you want space heaters without fans. When we look at air cleaning, so there are just a number of types of filters. What we're doing with the filter is we're trying to approximate clean outdoor air, right? The EPA in the States, we have the Environmental Protection Agency. They've set standards for contaminants, 6 common contaminants in outdoor air. And part of the design process for the HVAC system entails confirming that the outdoor air that we're going to be using, this is going to be the basis for the indoor air, we want to make sure that it is sufficiently clean. Depending on what the contaminant is, we may have to either document some sort of strategy for making that air clean, or ozone or particulate matter, we have to apply certain types of filters. Right, and so there are many, many types of filters. Some are well-established and understood technologies with demonstrated, like the plain Jane mechanical filters, and then we have some that are newer, more advanced technologies like the UVGA, the photocatalytic air cleaners and ionizers. Have been talking about filtration. Common filter is the mechanical filter, and a lot of folks have been, at least when the pandemic first started or got underway, and people were looking at what they were going to do in their buildings, folks were talking about adding HEPA filters. Everybody wanted to get a HEPA filter. We do not recommend HEPA filters. So obviously these are the filters that remove 99.9% of particles, and but we don't recommend them for a couple of reasons. One, many viruses are actually smaller than the for which the HEPA filters are rated, but also the MERV rating system correlates to the minimum efficiency across the particle size for the filters, and how the filters operate. They actually perform their worst typically around 0 micrometers, both above and below this size range. The filters tend to be a little bit more efficient. That efficiency, just like extra ventilation, it doesn't come without a price. It comes with additional pressure drop or resistance to airflow. As the MERV number goes up, as the pressure drop across the filter, and this means that the fan is going to have to do extra work to move that air through the filter. So this leaves us with a couple choices. One, could leave the fan operating at its current speed, and our new pressure drop will perhaps not be as great as the old level, but our airflow will fall off, right? And so then the filter is pulling contaminants through the filter as you don't have as much air as you actually need. And so this is really not the choice that you want to make here. The other choice is that the fan can deliver the right amount of air, right? right amount of air to the space. But when we do that, we can see that our horsepower goes up. This graph here, which is just a a cutout here, as we as the static pressure up, we can hear that the airflow goes down, so we're losing that. But we're also seeing our brake horsepower is going, right? And let me move this so that I can see a little bit better. And as we continue to do that, the airflow just continues to drop and brake horsepower continues to rise, right? So instead of selecting, HEPA filters that are going to have a significant pressure drop, much higher than the filters that were likely already in the system, what we're suggesting here is that folks look at levels between 11 and 14. And we go down to 11 because a lot of facilities have older buildings, equipment that was designed, particularly in schools. We see a lot of unit ventilators, and these systems were filters didn't even have MERV ratings, or if you did an equivalent MERV rating for what they are today, it would probably be MERV 3 or MERV 4, right? It wouldn't even be the typical MERV 8 that you see as a now. And so we're suggesting that folks go with something, again, between 11 and 14. They can get these in low drop models, and also tend to be more available, right? Because everybody's looking for these for better filters right now. You're looking for them, and everybody at time. So now as the cost of the filters gone up, and they would have gone up anyway because higher MERV filters more expensive. For example, a HEPA filter, a 12 by 12, 24 by 24, 2-inch or 12-inch HEPA might cost $500. If you were to get a 24 by 24 1-inch filter, that $10, right? $15. So significant price increase. And on top of that, the availability, right? Because everybody is demanding these filters. So lead times out the wazoo, right? They're just not acceptable for most applications. In addition to the mechanical filters, we see folks adding some sort of advanced technology like UVGI, ultraviolet germicidal irradiation. We're using, energy in the ultraviolet range that renders the microorganisms, render back the virus and other microorganisms as well inactive, right? So when you want to go beyond the typical mechanical filter, then you can include some of these technologies. They can be installed in ductwork or in the air handlers, or they can be installed as standalone equipment. Particular technology, UVGI, has been around for a very long time. It's very well documented. It's frequently used in hospitals and laboratories, municipal water treatment facilities. It is also used in schools and in commercial applications. And this is a very, very effective strategy for contaminant control. However, if you do intend to add this to your system, be aware that PPE is required for maintenance. Radiation causes sunburn and can damage eyes, and long-term exposure can have other health, contribute to other health challenges as well. So be aware of these things. You also want to take note that older VGI systems use mercury vapor lamps or some sort of inert gas. Some of the newer systems are using LED lamps, and I apologize that this emerging technology button is right over the LED, but some of them use LED lighting. And LEDs, while they're more efficient for energy use, they are not as efficient or effective at getting rid of the virus, right, of the pathogens. So you just want to, be careful when you look at those. There are some other new technologies akin to UV is the photocatalytic oxidizer. This uses UV light to react with a chemical catalyst. It acts on water molecules in the air, and they form hydrogen and superoxide ions, which oxidize the organic compound. They eliminate the microorganisms. This technology has been around for a while as well. However, it is considered an emerging technology, not because it's new, but because there is scant little third-party data to substantiate the efficacy of this technology, and that's for the ionic air cleaning as well. With these two technologies, you want to be careful of a couple of things. One, in particular, the photocatalytic oxidation. It does use UV, but it doesn't always use UVC, which is the band that is most effective at getting rid of the microorganisms. Sometimes it does use UVA or UVV as effective. And excuse me. And some studies this is not that great of a technology, if you will. Indicate that it is very effective. Some studies indicate that there's not a lot of studies done in the HVAC arena with these technologies. They've been done in laboratory settings, but not specifically looking at HVAC test setups. The ionizing air cleaners, similar to the photocatalytic oxidations equipment. You want to be careful with these because one of the challenges here is that they can produce ozone, right? So these kind of operate to ionizing air cleaners that you may have seen in the past. Instead of they have a DC voltage that gets applied to the wires, and so they create the ionizing field. But instead of charging those particles so that they agglomerate into bigger particles that are then precipitated out, actually send those ions out into the space where they continue to interact with the organic chemicals. So this too is a derivative technology, but again. So you just want to be careful when you're using these. There is a significant, I guess, of anecdotal. We do see folks here in Michigan using these technologies. I'd be curious to see what you guys are doing there in Greece. But here we do caution folks to definitely to exercise due diligence when they use these. To verify effectiveness for these new technologies, we encourage folks for any freestanding electronic filters that they use to check to see if on the Associated Home Appliance Manufacturers list. This body has jurisdiction over this equipment, and they test to make sure that the equipment is able to remove dust and environmental tobacco smoke, and pollen, as well as they certify the ozone production. They make sure that it is below the allowable limits for this equipment. Use this technology. You also want to make sure that any equipment that you might use listed by UL or the comparable body that you have there in Greece. This particular safety testing, again, is looking at the level of ozone production for this equipment to make sure that is below the acceptable levels. When we talk about humidity control, lots of times we think about humidity unless we're talking about the heat out in the summertime. But humidity actually in spaces matters. It matters to our bodies and it matters to our buildings. Our bodies are more than 60% water, and our good health depends on a balance of moisture both inside and out. In warm environments, when the humidity is high, we run the risk of overheating, getting cramps, fainting, suffering heat stroke. When the humidity is too low, the mucous membrane, nasal passages, and our respiratory tract can't effectively do their jobs of humidifying and filtering out particles from the air that we breathe. Our bodies, again, 60% water, so they do well when we drink 8 glasses of water a day, and when that are maintained at relative humidity between 40 and 60%. I like to say that that the Creator was really looking out for us when He did, because that sweet spot for humans is not so sweet for viruses and other contaminants, as you can see here. So this graph here comes straight from and we can see here that this ideal range of 40 to 60% relative humidity. Now in Michigan here, we do talk about and suggest that folks, that we expand that range to 30%, particularly places that may not be able to handle higher relative humidity level. A lot of buildings are older, they may have single pane windows, they may have a lot of woodwork if they're old houses of worship, and the 40% in the wintertime may not be achievable. And so if we can at least get to 30, that's something. And just to be clear, that 40% number, that is for the winter level, and the 60% level, that would be for the summer. And this information is this data regarding optimal humidity levels is fairly old, but we're still doing testing in this area. And actually, the claims there regarding the humidity level are some research that's been done. This graphic here on the left here, this is done by Dr. Stephanie. She is part of the she's an ASHRAE distinguished lecturer, and she's part of the environmental task force. And this was a study that she did. She was involved with for a Chicago hospital in I think it was in 2013. They looked at 10 patient rooms and studied those patient rooms for about 13 months. They had over 8 million data points, and 400 patients went through those rooms. At the patient's incidence of hospital-acquired infections as building performance metrics varied in those spaces. And what they found was that, sure enough, when the relative humidity was low, you saw more infections. When the relative humidity was high, when it gets up into that 40% range, right, the number of infections goes down. In some cases, in a couple of days, it was even down to 0, right? And then here again, this is a research project that was done. This is not an ASHRAE research project. This was a research by Lisa Casanova, where she was looking at actually coronaviruses. So we call this particular coronavirus that we're dealing with a novel, because we have had other coronaviruses, right? We've had SARS, and we've had MERS, and others as well that we've been. And so she was doing some research in this one. This was about 2010. This research project was going on, and what she found was that similar to others, that at that sweet spot between 40 and 60% relative humidity, the virus. Sorry. Okay, I'll keep going. I thought I heard something. Yeah. Ooh, I can't hear you, but I'm just going to go ahead and. So on this particular study, they were looking at the viability of the virus at various temperatures and at various relative humidities, and they found that at at that sweet spot between 40 and 60% relative humidity, the virus was inactivated faster than it was outside that sweet spot. So both below 40% and above 60%, the virus lived longer, as much as like 28 days, and they were more virulent. So even though, and I'm not sure, how things are done in Athens there or in Greece. In Michigan, most buildings are not humidified. It takes a special building. It's either a library or a museum or a hospital, someplace where the application actually calls for humidification. Your average building here in Michigan is not humidified. And so this is something that would have to be added to systems. Could either be added, if there's space in the existing air handler, it could be added there. Otherwise, possibly in the ductwork. A lot here in Michigan have boiler systems that do not actually have ductwork, and so we would be looking at in-space applications. When we're doing that, we want to make sure that, for example, if we're putting it in the air handler or in the ductwork, that we've got enough downstream absorption to handle moisture that would be provided by that humidification system. Whenever we're looking at humidification, the big concern is always condensation. And so you want to make sure that not just the ductwork and the equipment, but also the building envelope, consider the windows, consider the thermal insulation, and all of the relative humidity levels above 40% in the wintertime. A couple of closing comments. There's some resources. So the Detroit chapter here, and understand that the presentation that I'm sharing with you, this is kind of the presentation that we give to end users. So we've given this, we've shared this with our state in various forms, so there is this document. If you're interested in it, you go to our website and you can grab a copy of it. This is a compilation, if you will, of the recommendations that came from the Society COVID-19 recommendations, as well as some things that we pulled together here ourselves, local chapter members. So it's just a 6-page document that covers all of our HVAC components, your chillers, your air handlers, as well as the components inside the air handler. So your filters, your humidification, your cooling coils, looks at your drain pans, your fans, and it provides just some recommendations of what building owners and building managers might do to use that equipment to help mitigate their risk or reduce their risks of aerosol transmissions in the facility. It also looks at domestic hot water. It looks at domestic water, and it does include some detailed on water system flushing. We typically also always refer folks to Society's resource page, where they can get additional information. And I'm sure you probably are familiar with it. You probably have looked at it a number of times. It's updated on a regular. They've made some significant updates a couple of weeks or month. But they do talk about, again, recommended actions. They provide some really good technology overviews. And there's some specific guidance for various building types. So, stuff for hospitals, stuff for schools. So they actually we had elections here in the U.S. Back in November, and they had recommendations for polling stations. So very, very good resources there. Also, we typically try to remind folks that when you're looking at making modifications to your system, it's a really great opportunity to also look at possibly recommissioning or retro-commissioning A lot of times things have, drifted, performance has drifted from design. Things just get out of whack. And very often, as I said earlier, maintenance budgets get cut and some get done. And so this is, the perfect opportunity to go back and look at things and make sure that your systems are not just properly and working well, but that they're also meeting the criteria, the current criteria for the building, right? And then also another document that a lot of folks aren't necessarily aware of, but Guideline 29 is really helpful. It's a risk management. It helps you put together a risk management plan for public health, and it considers all of the major building systems. In addition to HVAC, it also looks at utilities, and it's giving consideration to releases, radiological releases, chemical releases, fire, all sorts of things. So that's a really, really great tool that you may want to check out. And then also, you want to look in the future. ASHRAE currently doing some research projects. So they've got some research projects that are related to the spread of infectious disease. So they want to keep it these and look for the results when they do get published and when they do come out, or if there are ever any interim reports, or look for these at upcoming conferences. Some of these are will be very useful and very helpful as we move forward. And I want to leave you with just a comment here from, or a quote, if you will, from our president. And just a couple of things that he said here really just kind of, struck me as very, timely in terms of relation to what we're experiencing around the globe with COVID. And, the world is evolving, right? And we need to evolve too. And we need to invest in technology. And oftentimes when, we think about particularly maintenance, and I'm going to, because I'm chair of TC 7.3, often when we think about maintenance, we think about, the equipment that we're going to use to the maintenance, or the equipment that we're going to use to track and trend the maintenance. We don't always think about investing in the people managing our facilities. And these are, we also need to give that consideration, significant consideration. I was listening to the radio today, and they were interviewing a maintenance worker, a janitor actually, on a college, and she was talking about how how important her role is, and because they were calling, we were referring to folks as essential workers, and she was, she's an essential worker, but she's always been an essential worker. But now it's even more important, and it gives the buildings on campus, it gives them a sense of comfort, seeing her and her staff there, seeing them do their work, making sure that things are clean and well kept and in good working order. And I would suspect that that is the same whether we're in COVID or not. ASHRAE is real big on facility tours. We do this often here at our our meetings whenever we can, and everybody always enjoys the nice mechanical room, right? Nobody wants to visit the dirty room, and I would venture to guess that the folks who clean mechanical rooms are probably happier folks who work in dirty, unkept, poor maintained mechanical rooms. And so we want to make sure that we're investing in maintenance, because that is going to be so key going forward. And people are very interested these days in the experience. People talk about the building experience, and the building experience is in the first couple of months of when a building goes up, that experience is largely based on the design of the building, right? But a year down the road, 6 months down the road, the experience that somebody has in the building is based on how well the building is maintained, right? And so we want to make sure that we understand that, and that we invest on that side. And as our president says, those that don't are going to be left behind. And for rushing, I was trying to get a lot in just 30 minutes. And I think I did that. I've got a clock here, and I think I'm a minute over. So I will end there and say thank you. If there are any questions, retain them. And so I hand things back to you, George.
Thank you very much, Sonia. Thank you, really. And also, I haven't mentioned in the first place that we would like to thank you for one more reason, because you have right now in probably 15 minutes or something like that, another presentation to make, but you managed to find some time and squeeze into our event as well. So this is why we're going to have questions for you right now, and then we're going to let you go and prepare for your next presentation. So right now we don't have any questions from the audience, but we have our member of the board, Alkis Triantafylopoulos, also along with us. And as you probably have seen, he has posted a couple of questions in the chat, but I think it would be better for listen to him and maybe ask a couple of questions, or maybe more, as I can see, live.
Okay.
You are muted, Alkis.
Sorry for that. Hello from me. Greetings from sunny Athens. Hope you can get to visit us as soon as the whole thing is over. Would like to have you here.
I hope so too.
Yes,
I hope so too.
So the idea for me to write a few questions on the main chat was to provoke a little bit the others and stop making them feel shy, maybe because most of them are going to be in English. They didn't, so I'm going to address them to you directly. As if it was them. One of the things that you said in the beginning is when you start, reopen, or maybe recommission the ventilation units, you should also check for the sensors operation and things like that. And what we've seen that usually not just the operation, if they operate or not, like in 0 to 1, but if they're calibrated accurately, and especially in humidity sensors, for example, the accuracy goes along and the calibration goes along with it. And if a unit is not in operation for 6 months or a year, maybe more, then these calibrations will be way off. So any tips and tricks how we should trick with those, how we should operate with those?
If you can, field calibrate them, that would be a. You may reach out to here in Michigan. We might use one of our test and balance or test adjustment contractor might be able to do something like that, or we would send out a calibration service provider to go and take a look at those. So calibrating is not something that you often, right? You hope that the sensors are going to be that they will hold their calibration. But you can send out, again, a calibration tech to either to do that in the field, or if they can't be field recalibrated, you may have to either, send them back to a calibration service provider, or they may just have to be replaced. Unfortunately, sometimes that does happen as well.
Yes, I see. Another thing that you did mention is like you suggested that if the airflow is probably not good enough, if we don't have many air changes per hour in some areas, you suggested we should probably open windows or maybe add some extra fans to supply pressure and exhaust. So, which is probably what we've been doing mostly, or everyone's been doing mostly lately. So this breaks in two parts. The first thing is what happens with the energy efficiency side of things, and not only in general buildings, but in some cases we even have regulations and energy certificates and LEED and BREEAM and things like that. So what happens on that side of things when we open windows or we add more air, unventilated or not, This is my
Yep,
first.
absolutely. Yeah, so this is a balancing act between indoor air quality and energy. And so you may have to find yourself sacrificing energy use for the short term in order to gain the air quality in the long term. And I just want to make sure that I'm clear also. So when I say, you know, opening windows and doors and things like that, that was for the that's largely for that initial flush before you bring people back into the facility. Once you know, once you've got the system operating, once you've brought people back in your system, you really want to make sure that you look at whether or not you can have doors and windows open. Sometimes that stuff kind of interferes with the operation of the HVAC system, so you want to make sure that those things aren't competing. And then I know that LEED has, depending on if somebody's doing a new construction building or if they're doing an existing building upgrade, but US has instituted some credits, if you will, or certain things related to reopening the facility. And I think that there are credits for looking at your and doing a water system flush. There's credits for doing an air flush. There's credits for doing enhanced, I think for enhanced filtration and air cleaning. So bringing in UV GI, I think you get a credit for that. And there's one more, I can't remember what the other one is, but there are 4 credits USGBC recently added to their Safety First program. I think that's the name of it. I apologize, I don't remember it exactly.
Which brings us to the other part, what happens to the filtration of these air that we're going to bring in. Like we bring more fresh air, either for flushing or a little bit to add up in the existing ventilation system because it's not big enough or the air changes are not big enough. And okay, I get the energy efficiency part because safety comes first. So I get that. But how safe is the air if we open a window or if we just put a fan and we don't have the minimum filtration that you have either in USA, you have the MERV factor, we in EU have the ASHRAE factor. So what happened with that?
Yes, so again, that's why I mentioned earlier that, you know, you want to take a look at whether or not you have windows open in the particular facility. Some facilities, you know, you don't want to have windows open, and you definitely want to have everything go through the HVAC. Are designed to do either natural ventilation or mechanical ventilation, and so you need to look at your system. You need to understand your system and see, you know, what it is able to accommodate. But in terms of you know, when you're looking at the filtration, I think only what's going through your HVAC system is going to get filtered. Right. And the other thing is when you're talking about bringing in you know, additional outside air, the ideal solution to or the ideal approach is to have that additional outside air replace other recirculated air, so that your total air amount stays the same. Right, you're just, instead of recirculating the surface, you're just bringing in inside air. Now, sometimes, you know, the system design doesn't allow you to be able to do that, but that would be the ideal approach.
All right, thank you very much.
Thank
I
you.
do have one more question. It's for Dimitris. Is Dimitris going to join us and make the question himself? Because I think he was in the attendees. Or should you address it to her and then I'll follow up?
I see questions here in the chat box that I can address.
Yeah. As you can see, we have some questions about whether you recommend either upgrading the filters and shorten their changes cycle in installation, or also if you recommend portable UV sanitizing units. Yeah.
So what we've been doing here, we do recommend upgrading filters, and the change cycle, how we would approach that is that you would, as you're monitoring things, because you know when you make a change, you're going to monitor and you're going to monitor, and perhaps you would under regular operating conditions. And so you're going to be monitoring things to see how frequently it does need to be changed. If you're in your value, it is very likely that your filters are going to need to be changed more frequently. And so you likely will be doing that. And so most owners are going to, again, do this tightrope walk, this balancing act between increasing their level of filtration, what that's going to cost them, because that can get a little costly. And then the other question is the portable sanitizer sanitizing units. Yeah, we see those being used a lot of classrooms. There's a manufacturing unit that's designed specifically for classrooms, and we see those units being used there. We also see existing air handlers and rooftop units and unit ventilators being retrofit with UV lights. So if there's space and that it's depending on the type of equipment, it all depends on what kind of equipment you've got. But I guess the best place for it would be in the central system. And that way, maintenance is easier to do. If you've got, one, in a versus, 100 lamps distributed throughout a school building, right, in a bunch of unit ventilators. Most people, the one in the rooftop unit or the one in the air handler instead.
What I see is more feasible on that. What I think or I believe people would prefer is the portable and the plug and play solution for two reasons. A, doesn't affect, especially those that have UV and HEPA filters, because a lot of local portable devices have both technologies, UV and HEPA filters. So I don't know if it actually does more work than the UV. It certainly makes them feel better because they read the two most favorable words, UV and HEPA. So they say, I'm clean, I'm sanitized. And I don't know, I'm not sure if there is a reason for UV and HEPA, or if when you have a UV, HEPA is not needed, because I understand that from HEPA filters, I know from HEPA filters, there are some diseases, some viruses that can go through. But when you have both, I guess it's going to be better. If not, what would you recommend on that?
Yeah, you're absolutely right. It makes people feel more comfortable. But if people are, again, playing this, doing this balancing act, adding the UVC is, while your electricity use is going to go up slightly, the additional from that versus the additional energy for higher MER filters and the additional filter cost and filter maintenance cost. Typically the air cleaning is a better way to go. It's a less expensive way to go. But folks like to, particularly right now, folks want to feel safe. Folks want to feel safe.
Yeah, and I would like to add also that I think right now we are in the verge of the whole situation that psychology is one of the major issues right here, and probably things that make people feel not particular, it's the proper one, but make people feel that they are safer. Probably they will work even better as well.
Yes.
Okay, so I think because it's 6:45, I think we have to let Sonia, because she has also another event to attend as well. Thank you very much, Sonia, once again. It was very nice to have you here, and hopefully we will have you once again in our event, even better in live event, so you will be able to visit us. Thank you, Thank you very much.
I would appreciate it, and I was extremely nervous. So I apologize for any mistakes or missteps that I made.
No,
but I'm really happy to be here. Opportunity.
Your presentation was great. Thank you very much indeed. Thank you.
Thank you. Bye-bye, and good
Okay.
luck to the rest of the panel.